Now how to overcome this hazard, or what is the hazard cover? Okay, so this is basically the static one hazard. Now let us move to the hazard cover for this part. So for that, let me take an example. So I am saying let there will be example y should be equal to bc bar plus ac. Now here hazard will occur when C make the hazard will occur when C will make transition from 1 to 0. Now when C moves from 1 to 0, there will be a static one hazard, because you will see in the first term C bar is involved and the second term C is involved. Okay, so there will be a mismatch between calculating the two product terms AC and BC bar, because AC is directly available, and to calculate BC bar there will be a problem of delay because of the NOT gate involved with the C bar. Now how to solve this one? Let us try to plot the K map for this one. So I have here K map drawn. Okay, so for this K map I will fill up the table. Let us say there is a B and C, 4 combinations 0 0 0 1 1 1 1 0, C is 0 and 1. This is the equation of SOAP form. Okay, this is the equation of SOAP form. So I will fill up once in the K map. Now what I am doing actually here is I am reversing the procedure of K map. From equation I am going to fill up the K map. Okay, generally we write down the equation on the basis of K map, on the grouping of K map. So first group I have is AC here. So first of all I will write down for AC. Now for AC, A bit is present in these two columns, B is present here. How to replace it? A is present in these columns. Okay, so A bit is present here, A1 and C1. So common bits for these three parts AC is these two. So this is a group of 2 for which I have written the equation AC. And for BC bar, to get B, I have common bits here B. So I will mark here B, and C bar is here correspondingly. So this is another group, BC bar. Okay, now there is a hazard just because of C's transition from 1 to 0. There will be a hazard. To overcome this hazard, what should I do? I'll make another group, this one, the group of 2. Okay, then what will be the equation? The equation will be modified to y is equal to BC bar plus AC, which is already there, plus the added term in the red part, this group of 2, which is nothing but AB. Okay, now when I modified this equation, this corresponding to circuit diagram, if you plot the circuit diagram, what you'll get here, C is making transition from 1 to 0. Okay, so definitely this is gonna affect these two parts. Okay, but if you write the equation, this one, what will happen? Whenever the C will make transition, these two parts will be affected, but at the same time A and B will be making sure that the output should be confirmed, because AB is 1. So let us take A, B 1 1. So what I'm taking is A is equal to 1, B is equal to 1, and C is going from 1 to 0. Okay, if C is going to 1 to 0, definitely AC will be calculated as 0, BC bar will be again 1, because after C is going to 0, then 0 bar is calculated 1, but it will take time. That is what is the static one hazard. But before this calculation is done, AB part will make sure that the output Y is 1. That's why the hazard is covered. And the important thing is that there is no other hazard possibility in this circuit, and the inclusion of this extra gate or the extra grouping does not affect the truth table. Yeah, definitely it will increase the size of the circuit by we are adding up one more AND gate here, but definitely the circuit will be hazard free. So that's all about the static one hazard. Now let us move to the other topic, that is static zero hazard.